Welcome to Lunch with Tech Leaders, where we have engaging conversations about software development and cloud engineering with industry leaders and subject matter experts. These episodes are created by the Great Lakes Tech Leaders, an online community of technology practitioners. Please come join the conversation by visiting gltl.rbn.ai. Again, that's gltl.rbn.ai. Now strap in, because we're deploying to production in 3, 2, 1.
Hello, everybody, and welcome to the latest episode of Lunch with Tech Leaders. My name is Adam Oberhausen. I'm the VP of Customer Solutions at Right Brain Networks, and I'm your host for today. Joining me today is friend, software, and data consultant Tom Kowalski. Say hi, Tom.
Hello.
And our good friend Joe is missing in action today. Not sure, but anyways, we're going to be talking about some programming paradigms today. In particular, we're going to be discussing the nuances and differences between OOP, which stands for Object-Oriented Programming, and Functional Programming. With that, kick it over to you, Tom, to introduce our subject matter experts today.
Yeah, I'm excited about this. I'm dabbling in kind of my own little paradigm that I've been putting together. It's like a mix of everything. So I'm excited to talk about this and get everyone's thoughts on it. So with that, we brought back Shafiq. I'm gonna say hi, everyone.
Hello.
And joining us as well with Mike.
Introduce yourself.
Yeah, I'm Mike Onslow, Director of Technology at Clarity Voice. I've been in the software space for about 23 years. Have done OOP, functional, everything in between, right? So,
all right, I'm
Great to have you here.
Thank you.
Well, I think I'll just probably kick it over to Shafiq. This episode was your idea, Shafiq. You had said you'd done a recent talk about this particular topic. So I would just like to, I've got some things I want to talk about, but I thought I'd just start by opening up the floor to you, and maybe you could just share your thoughts and how you presented this material at your recent event.
Yeah, maybe we should just start with a punchline right away. So
yeah, exactly.
We don't need any teasers or anything. So the bottom line was having a hybrid approach in your applications is probably the best way to go. So in the talk I gave a somewhat detailed view of what we do at OpenDoc, and I think it's something that it's kind of evolved in my mind over the years, and it works pretty well. It kind of combines the strengths of functional and OOP, and while avoiding some of the the weaknesses of both paradigms. So the hybrid approach is kind of the key. It seems to apply to other aspects in life in general. So that's kind of the punchline.
Okay.
OOP, when I say OOP, it also includes kind of the imperative paradigms as well. I mean, they're more similar in my mind. Object-oriented programming and imperative programming is kind of they're clumped together closer in that paradigm space relative to functional. And really, the experience I had with functional programming was I kind of got into Haskell for 3 years or so. And that was kind of a mind-bending experience. I think it was very insightful and interesting. And so now I'm kind of back from that world and trying to do the hybrid thing.
Okay, well, let's take a step back and start with some simple definitions. Like maybe Mike, if you don't mind, in your terms, how would you describe OOP? And then how, as if I'm a child, explain OOP to me, and then explain functional programming to me, so that someone with limited understanding of programming could maybe grasp some of these higher level concepts.
yeah, I like what Shafiq said about imperative, right? And I do feel like if I'm to explain it to people, I'll say that with object-oriented programming, I'm going to do the 5-year-old, or at least the very simple, and then we can expand on that if we need to. But with object-oriented, a lot of times that, we're coupling that, or not coupling it, but we're essentially, using an imperative method, which is, I want you to do it. I want you to do something, and I also want you to do it like this, and giving it very specifics, right? Where at the inverse of that is declarative, which I found that functional programming lends itself well to a declarative approach, which is sort of like, here's the outcome I want. I don't exactly care how you do it, right? But we want this outcome at the end, right? And there's a lot more to it. Obviously, I could talk on object-oriented. I will say that object-oriented, we're taking these classes and essentially extending from them, right? And we're also encapsulating the information as well as the way that you're going to act on that data and information in the same nomenclature, the same entity, right? Where it's functional, you're taking your data and your functions and you're sort of separating that and you're transforming it down the line, right? So you're going to get something out the other end, but you're not going to, you're not going to be mutating that along the lines generally depending on what you're using. And I've used Elm as one of my functional languages, which is purely functional, which essentially this means that you don't have any direct side effects, right? They're all going through essentially a backplane, kind of like Haskell. And then I've used languages like Elixir, which is more akin to, it's definitely immutable, but it feels more functional, right? Or more like object oriented, right? Because you have some state mutations or something that along the lines using recursion sort of feels like a state mutation. So sorry, that probably wasn't the 5-year-old.
Yeah.
Do you have kids, Mike? I gotta ask.
You know what? I do. You know what? Listen, both of my kids are professional programmers. Now they're 8 and 13. Yeah, I do.
All right. So I'll ask a certain AI model to explain this to me as a child, and this is what ChatGPT told me. So for OOP, it says, imagine you're playing with a toy car. This toy car has certain features. It's red, has 4 wheels, has doors, can open and close. These features are like the data in OOP. Now imagine the things you could do with the toy car. You could drive it around, open its doors, or pretend that it's flying. These actions you can do are like the methods or functions in OOP. I was like, okay, that makes sense. And then when I asked about functional programming, it said, let's say you're making a sandwich. You have the steps to follow to make the sandwich, right? First, you take the 2 slices of bread, then you put the peanut butter on one side, jelly on the other side. Then you put the 2 slices together. Each of these steps is like a function in functional programming. In functional programming, we're focused on the steps or functions, and we try to make each step as clear, as simple as possible. We don't worry about things like the sandwich ingredients until we actually need to use them in a step. I don't know. I just thought it would be fun to share what a large language model, how much it could simplify some of these concepts, because it is hard to follow, even as someone who's been programming for decades. Like the things that you guys say, the words, the just all the technical terms. It's hard to keep it all, make it make sense. It's very abstract, even to someone who's in the know. What are your thoughts on this paradigm? Or I think you were nodding your head a lot when you talked about taking a hybrid approach and what your current job demands are. Anything you want to share, insights on paradigm here we're talking about?
Yeah, I don't want to derail it, right? But the paradigm that I like to think of things now is not necessarily object-oriented or functional. It's more of thinking in terms of observations, right? All data is just an observation, whether it's external or internally made of a decision. And that's really helped me out. And it kind of plays into both, right? You kind of do need to define your objects, but it lends itself more to the functional sense, and you're making decisions based on this data coming in. So, but yeah, maybe that's a topic for another time. Now I think of that, but yeah, I'd love to dive more into what do you guys think of those definitions that we heard, right? ChatGPT, and elaborate on those.
Yeah, it is pretty hard to talk about this stuff. It's pretty abstract, if you haven't done it a little bit before. I guess perhaps another attempt at defining it is, functional programming is attempting to map inputs to outputs. So that's how you kind of think of functions. They're little devices that take an input and produce the same output for the same input always. And then you express your whole program in a combination of these things. Obviously, there's many other concepts, but that's the core of it, I think. And then, with objects, you're trying to model the world as objects in your program, and the objects have internal state, and they also have certain behaviors. And so those are the fields and methods defined on the object. That's kind of how I think about things. But obviously, there's overlap between the two paradigms and all sorts of other things related to it.
Yeah. So when I hear people talk about functional programming, they use a lot of words that I don't understand, right? But what you just said makes a lot of sense to me. But yeah, I can't even think of some of the, the offshoots of what they say and but like the side effects, like what you said of what you put in will always be the same coming out. And I love that. So when I do my own little programming paradigm, any type of business logic that I do, I try to model it that way as well, right? Even the time, right? There's nothing that can be, changing inside of there. So you pass in the time as well, right? Any environment variables into that function, anything that you need, right? So it's always the same. I think it's a pure function, is what they call it. But I don't know if that's the same as functional or if it's like a part of it, or like what other parts are there to functional programming?
Yeah. So can I take a little detour here? Historical detour.
Yeah, I love the history. It helps me. Stories help us, put things into context. That's how humans learn, right? So
Yeah. So I think this kind of highlights why the paradigms are the way they are. So if you go back to the 30s, so a lot of us have heard of Alan Turing, most probably, right? So he invented this concept of the Turing machine, and it's this abstract computer that can do, in principle, anything that any other computer can do. It can compute any computable function or program. So in my mind, the Turing machine model is kind of it maps onto the imperative / object-oriented world pretty well. You're manipulating a tape, and you're reading and writing state and all that kind of stuff. A lesser known person is perhaps Alonzo Church. So together they formed this thing called the Church-Turing hypothesis. Okay, so Alonzo Church was the inventor of lambda calculus, if you guys have heard of that, which is a mathematical framework for modeling computation. And turns out, through this Church-Turing hypothesis, it turns out that the two models are equivalent. So the Turing machine and the lambda calculus, they're equivalent, i.e. they can compute the same functions, no more, no less, right? They're equivalent classes. So what does that mean? That means anything you can do on a Turing machine, you can do using lambda calculus as well, and vice versa. The functional programming paradigm is basically an evolution of the lambda calculus, right? It's math-oriented. It's very based on functions. By the way, that's where the keyword lambda comes in many programming languages for anonymous functions. So lambda calculus kind of birthed this functional paradigm, and then the Turing machine style birthed this, imperative / object-oriented paradigm. So
interesting.
They are equivalent, and that's where they come from. But because of that, and because of the history, there's a lot of terms that come, from the old school math days, like, currying, maybe, if you've heard of that, immutability, all that kind of stuff, pure functions, all that comes from the, math background from the lambda calculus, which is pretty interesting. So that's the historical kind of backdrop for this. And that's where, a lot of the terms still linger from those days, even though they can seem very esoteric.
Yeah, some of those terms, pure function means function is considered idempotent. How do you say that word?
Idempotent, yeah.
Yep. Immutability, higher order functions, recursion, referential transparency. It sounds like you're in a high, a 400 level math class, basically.
Yeah.
So
I would say deterministic, right? It's the word, right? It's always going to be the same no matter what you put in, right? It's kind of the definition there.
Yeah, so the side effect aspect is a big part of it. It's the idea that when you run a function, all it does is a computation and nothing else happens elsewhere, right? So the side effects are everywhere in object-oriented programming. Like if I call a method on an object, I don't know if some database will be written to, or this, the global variable somewhere will mutate, or even the object state itself will change. So that's usually what happens. So there's a lot of side effects. So you call the function multiple times and different things can happen, right? If the function is idempotent or referentially transparent or pure or all those other synonyms or kind of synonyms, then that means when you call it, nothing else is happening. All you're doing is you're getting an output that is computed based on that input. It's just a mapping from inputs to outputs. Every time you get the same exact thing. So that's where the purity comes in. And it turns out if you enforce that kind of purity in the actual language, such as Haskell, if you actually enforce it at the compiler level, you can do some really neat tricks. For example, you can cache or memoize the results of a function, right? So if you know that the function is pure, then if you compute an input once, you don't have to run it again. You don't have to compute in the future. You can just cache that. Forever, the value will be the same for the same input, so you don't have to rerun it. You can't do that with object-oriented languages because you can't cache the result of a method because the method could have side effects, right? It could do something important that you can't cache, right? You're actually sometimes running it for the side effect itself. So that kind of stuff. I don't know, Mike, if you have anything to add here.
Yeah, the only thing that I'd love to add is, as I was kind of reading the description and we're talking about this, I want to mention that there are very few pure functional languages that truly enforce that, right? Like Haskell's one of them, Elmo's another one, right? But essentially, there are quite a few programming languages that are a hybrid approach, right? Like Elixir, Scala, F#. And so I just wanted to let folks know that that's out there, right? You don't have to go really hard to that one side. I'd say that's there aren't as many people doing that, right? Like I think this hybrid approach is actually pretty popular, and that's kind of like where I land as well.
I wish, all languages would allow you to define them, right? Like, yeah, let me do whatever, but I would love to say like, hey, on this function, it's pure. Don't let anybody, have side effects in it or, like a strict, right, on the file or whatever. I'd love to see that.
Pure is best, honestly. I mean, when I'm writing code, I go for purity as much as possible and taking side effects and trying to keep them to one section of the code, right? Kind of like a backplane that everything has to run through.
Yep. Yeah. So Tom, to your point, the enforcement is important. Because if it's just kind of optional, then the compiler / runtime can't make certain decisions because there's no guarantees. So that's why you don't see languages that let you say, okay, this section, this is just pure functional, this one's not. It would be kind of cool to see that, but that's definitely harder to implement from a language design perspective. And and if you don't do any guarantees, then it's not very useful. The guarantee is kind of where the power comes from.
Yeah, even if it was a language like JavaScript, right? It's not compiling. If there was just maybe like libraries that could do that for me, right? Like, decorate it, say like, yeah, this is, pure function. Don't let anybody touch the file system or, anything like that inside of this function or anything. Yeah. I don't know.
Yep.
We got some interesting questions, conversation going in the chat. I thought I'd just sprinkle them in here. Where... so Sir Lancelot, he says, take a shot every time you hear Haskell. What are your thoughts on the overhead of copying data in functional languages versus just mutating the underlying data in game programming, for example? Have you seen this? Does the question make sense? I can ask.
Yeah.
I can get Lance on here to okay, yeah, take a shot at it.
Yeah, that's a great question. So, I mean, there's all these, because it's more abstract, functional programming usually can be less performant, at least on paper, because it's doing more for you and you're not really controlling the metal, so to speak, as much. So there could be more overhead. One such example is this copying stuff, right? If data is immutable, then when you pass a variable to a function, you're copying it rather than using pointers or something like that. In practice, I think this is not a big concern, especially with modern hardware, modern language development techniques, etc. It used to be. It seems to be right now not much of an issue anymore. These are kind of constant time overhead that you pay for, and they will be optimized for you in some way, so you don't have to worry about it. Haskell does a lot of that. For example, the compiler is very mature at this point and will make sure to do whatever magic it needs in the background to be performant, but the user can still enjoy those guarantees, etc. There's lazy evaluation, other stuff like that with Haskell that makes it a little bit harder as well to reason about the performance. That's part of the drawback as well. But in general, it's more abstract, so it's kind of harder to see what's actually happening at the machine level, and therefore you can incur more performance costs. But I don't think they're an issue anymore. It seems to be a solved problem at this point. I don't know if others agree.
Feel free to chime in. But yeah, follow-up question from Lance is, can we talk about what side effects are? What does that mean when you say side effects of a function? We talked on that with object-oriented, and what does that mean?
I can take this one if that's okay with everybody.
Yeah.
So side effects, and Tom touched on this too, right? Side effects are something that essentially take you away from purity on a function, right? So a random number is a side effect, right? It's going to be different every time you run it. The time, right, would be different every time you run it. Hitting a data, connecting to a database and either reading or writing data, right? These are things that could be different the next time you run the function one time to another. So with pure functions, not having a side effect means not doing anything that could change, right? That output, as you mentioned, as folks mentioned.
Okay.
With the same inputs.
And also from the chat room, just to wrap it up, we've got from Nicole, just a question. It sounds like functional programming is for more specific use cases. If she needs to use a database, will it work? Like if you need to do I/O to a database, will functional work? I guess even I'm confused. Like, what is the use cases when I should use functional versus not? I think I'm most comfortable in the OOP world because I just think in terms of objects and that just makes sense in my brain. But there's probably been times when I've written functional stuff and not even knowing it because I'm using like a hybrid language, right? So what are the use cases?
Yeah, so think about writing to a database. That's not good for functional programming. That's a side effect. That's intentionally, you want to change the world in a permanent way, right? In a semi-permanent way, you're changing a record. So that's not very amenable to a functional style. On the other hand, think of like some pure computation, like a math function, like computing the interest payment on a loan. That has specific inputs, and your output is always the same given the same inputs. You don't have to change a database somewhere. You don't have to talk to the user I/O-wise. You don't have to get a random number, nothing. It's a pure computation. So that would be great for a functional paradigm. But in general, if you kind of want to think about real world applications, perhaps the best one is a compiler. So functional languages are very good for writing compilers themselves. Why? Because you can think of a compilation as just a pure function that takes source code and outputs some other source code or binary code, whatever the output is. And it's deterministic and there's no side effects, right? For the same input, hopefully you're getting the same output every single time. And you can model the entire compiler as a function that can be broken down into sub-functions, obviously. And that is something that can write, end to end in a functional programming language, and it would feel completely natural with no headaches.
Question for both of you: when you guys are working with your development teams, when you're scoping out work, are you at that level where it's like this should be this should be written in an OOP style, this should be written functional? Are you having those conversations in your sprints or whatever methodology you're using to actually get code into production? Are you guys talking about what paradigm that this functionality should be written in?
Yeah, absolutely. Mike, go ahead. I'll share after you.
Yeah, absolutely. There are definitely conversations around this. We're not doing any games programming or anything, though. I would say that I'm interested now to look at games programming with functional, just to kind of get an idea of where we're at in the modern age. But as far as like functional programming for doing just things without side effects, I would say yes, you're right. At the core of it, pure functional programming is best for that, for just, pure functions in and out. But the fact of the matter is, like Haskell and, Elm and other pure functional languages still allow you to do side effects. You're just doing it in a very specific way where it's contained, right? So I want folks to understand that you could still use Haskell to connect to a database or generate a random number and whatnot. These things absolutely work. And we have a line of business application where the entire front end is written in Elm. We have hundreds of thousands of lines of code on that. It's a pretty big application. And that is doing a whole bunch of back-end API calls and whatnot, right? But as far as, deciding what we're going to use for a specific case, I would say most of our applications nowadays are sort of written in an object-oriented style, sort of, I forget exactly what the saying is, right? But it's like the functional core and then the object-oriented where you're utilizing the functions. We're trying to write as many pure functions as possible. Everybody on the team, including like our contractors, understands that a pure function where there's an in and an out, right? And we're essentially, it makes it easier to test. It makes it easier to debug. It makes it easier to observe. So I think that we kind of write in a hybrid style now with almost every application. And I think that it's more of an overarching like nomenclature and sort of, I want to say like convention style or like our standards where, when we're doing code reviews, we're looking at it, right? We're looking at where side effects are, like even stuff like logging and whatnot, right? Those are also side effects, right? You're writing out to external service and whatnot. And we're trying to contain those to specific points in the code where it's only going to happen here as kind of a backplane to the rest of the application.
Thanks for that, Mike. Shafiq, anything to add? How your team kind of dissects that paradigm?
Yeah, so I mean, just to respond to some of the chat comments. So obviously, like we said at the beginning, you can do everything with either paradigm, right? So it's not a matter of can you do it, but it's a matter of like, does it feel comfortable and natural? So yes, you can do side effects in Haskell, and that's using monad. It's kind of really genius ways of doing that in a contained way. But does it feel natural? I would say not really. Certain things like even just adding a console log style thing to your function, you can't really do that in Haskell. That's something, an intuition you would have very strongly if you're an object-oriented programmer. You simply can't do it in Haskell. So it's kind of weird and clunky feeling when you want to do side effects. But I'll tell you what, my team does, and this is how we've kind of transformed all this kind of stuff into a practical process on the team. So OpenDoc is a doc scheduling, software, SaaS software. So we split the application into a core library, much like what Mike was alluding to. It's a core library written in TypeScript that it's enforced using code review and other techniques. It has to be functional style. Okay? And it contains all the business logic. So for example, anything that looks for availability given a certain schedule and certain appointments, compute the availability of appointments between a certain time range, let's say. That's something our application has to do all the time. That's a core function in the core library that's written in a pure functional style. So any business logic like that, including stuff, by the way, like user permissions, can certain user with this role access XYZ resource. That's a function that returns a Boolean, right? Given the user and this resource and perhaps the current time or some other input, can they access that resource, yes or no? So that's a pure function. So we have all these, we have hundreds or thousands of these pure functions inside the core library. And what's nice about that is that you can write unit tests, because one of the huge advantages of the referential transparency or the purity is that you can write a unit test very easily. You can just inject inputs into this function and check that their outputs are correct. Done. And so we have this massive, unit test suite that tests the core library. And then for things that are input-output, that's where we use OOP. So OOP is very good for input-output. So, we have controllers that manage API calls, inputs from parameters, JSON, marshalling and unmarshalling and all that stuff. That's not easy to do with functional programming. So we use this kind of standard natural object-oriented programming there, and it works very well. So the OOP code interacts with the world, input, output, databases, etc., networks, and then it calls these pure functions from the core library and done. It's been very successful. And that's something, that's what I mean by hybrid. That's something I think I'll keep doing, until there's something better that comes up. But this has worked very well, and it's kept the core logic very well tested and solid. And so we never have like business logic bugs, right? And then also it keeps programmers happy because they're not shackled by the unnecessary constraints of functional programming when it comes to things like input output.
Just out of curiosity, are you using TypeScript for the non-functional?
We're using TypeScript for both. So
Okay.
TypeScript is a pretty awesome language, and it's got its problems, but you can do functional style very easily with it. And also, obviously, you can do objects. And so that's where it's a little bit hard. You can't tell TypeScript that this function has to be pure. There's no such concept, but we enforce it at the code review level and at the automated unit test level, and it works pretty well. 99% of the time, no issues. Every now and then something sneaks in and we'll have to kind of fix it, where there's some side effect, usually some function, we don't want that, so we'll have to fix it. So it's not like Haskell where it's 100% guaranteed, but it's close. We're getting there.
Thanks.
I wonder if there's something
yeah,
out
we're getting
there, right? Like now that I'm saying it, like there's got to be some, I don't know if you use Visual Studio Code or whatever, like VS Code, some extension that you can say, hey, tell me if it's, pure function or not, right? It dives through and checks all the code inside of it. I don't know. It'd be nice.
Yeah, it's hard. It's hard to detect side effects. If you think about it, like you'll have to do a full trace of all the functions and make sure that, the function that you're calling, you have to make sure it doesn't have side effects either. It's set up.
Yeah.
So if it's not baked into your language design, it's really hard to do that. But yeah, maybe.
Yeah. So we're getting close to time. I'm going to invite Lance up on the stage here. He wanted to talk about the quote from Alan Kay, and he thinks there might be some that OOP is misunderstood. So Lance is a frequent host of the show, friend of the show. Lancelot Carlson, co-founder of HealPay. Welcome to the show. Talk to us about this quote from Alan Kay.
Yeah, I mean, it's an interesting mental exercise. I think of it as he was thinking about OOP as this message passing thing. Everyone compares the analogy of like the chaos theory idea where you create little objects and then they sort of like, from these little objects, you can then create a system because, they're all interacting with each other. It's an interesting idea, but I think that the local retention is interesting. I think at OOP, everyone emphasizes like this encapsulation of state mutation inside of the class. And I think that the way that languages implemented his ideas kind of went off the rails, like C++, like everything is class oriented instead of object oriented. And so, and his emphasis was more on message passing. What are you defining as far as like defining the and when we say message passing, it's like the public interface for which you are speaking to other objects. And that was really more of the emphasis rather than this sort of class-based hierarchy, inheritance, that kind of stuff. Like I think OOP got a bad rap.
I feel like that happens to any term, right?
Yep.
In technology, turns into something else that was completely the opposite, like DevOps, right? It's now means completely the opposite of what it used to be when it started off. So yeah.
But even with message passing, so that is a nice way to think about it. So when you call a method on an object, you can think about it as you're passing that object a method, a message, right?
Mm-hmm.
So you're saying, hey, do something, or hey, something happened, whatever it is, it's some message that you're passing to the object. However, I think there's still the concept that the object maintains its internal state, and it does something with that message. It might store it. It might update some other parameters. It might reach out to another object and do further things, which have further side effects. So I think that's still in there, and that's still implicit in the message passing paradigm. So you're not going to escape this side effects business, right? No matter what you do, like it's baked into object-oriented pretty strongly because each object has some internal state and gets manipulated over time. The reason why that's appealing is because a lot of the real world behaves like this, right? Like bacteria and cups and humans and cars and all that. You can pretty easily, at least on the surface, you can map your problem onto object-oriented programming pretty quickly. That's why it's appealing. I think it's very intuitive in that sense. But the drawbacks are it becomes hard to reason about when you have this chaos of tons of objects interacting with each other, holding their own state. When you come back an hour later, all the objects would have different states, and now you have to reason about them differently. You can't use the same reasoning, right? You can't guarantee certain things, and so it's harder to reason about, and perhaps harder to find bugs, etc.
Yeah, it's interesting. I've looked at the Elixir and Erlang community quite a bit, where they do a lot of this message passing stuff, and you still run into this issue of, okay, I've changed one side of it, of the message passing, and then the other side, it gets corrupted because of, all of that. So there's problems on the functional side as well, where when you're mutating the messages back and forth, and so you have to handle that somehow, versioning that goes along with it. I just think that yes, I think that people have been using OOP improperly, where they've stuck too much mutation in their classes, and they haven't done enough to like make them small and them single responsibility, and that's where we run into a lot of issues where it's like if oxygen, the fundamental molecule was more complicated than it was. I mean, it still wreaks havoc on certain things, right? I mean, it oxidizes things, but like, if it wasn't as simple as it was, like, it wouldn't be useful to hook into other things. So, yeah.
I'll make a quick note about that because I'm glad you brought Elixir and Erlang up. So the back end of that same line of business system that I was talking about, and we have a few back ends written in Elixir, and I like the balance that Elixir strikes with the message passing. It's using recursion behind the scenes, right? But it feels very object-oriented. And I just want to echo that. You still run into a lot of the same types of problems, right? Because state is changing, right? State is hard. State changing is what's difficult, right, overall.
Yeah. Okay. We'd probably go all afternoon on this, but any last thoughts or comments, questions that you guys want to bring up before I wrap this up?
Well, strongly typed versus not. This is the next debate.
Tune in next week.
Yeah, we should have that sometime. That's another fun one.
All right, guys. I want to thank Shafiq and Mike for joining us today. Really interesting conversation. I hope the listeners find it conversation informative and valuable. We'd love to have you join us again next week, where we'll be talking about continuing our serverless series, focusing on security in serverless functions. As always, we're going to have expert guests and an interactive audience, and great audience today. Thanks for all the questions. Great to see so much activity in the chat, and hope to see you next week. So tune in.
Thank you.
Thank you.